Hello, my name's Evan Sinisak, and this is my recording demo for the INFO6019 and INFO6025 midterm project thing. So I took a very similar approach as I did for the Project 2 fireworks. And I basically took the ideas from that and to make this Canon program. So a lot of this stuff is the same or similar, with the change being instead of particles. I finally figured out how to actually inherit from the C particle class that we have been making in class with James Lucas, and I have a vector of pointers to the C Canon shot excuse me, class that I made that inherits from that. So part of what we needed to do for this is have an actual model for the Canon. So here are some global things related to that, including its initial position and initial rotation that it needs to face in the direction I want. And these variables get filled by the configuration file. The error callback, key callback, and mouse callback are all GLFW stuff. This load models from file is the same one I've used in graphics and the fireworks project. It just loads models into the VAO. And similar to the firework project, I have a add Canon shot function and an add mesh function that depends on the kind of Canon shot we're trying to make. So I had a strange issue where even though the config file was in the same place as the main, it wasn't reading if I just did read config.json. So I put in the full path to read it, which I guess we can go over first. So this is the header, made structs for each bit of information that we need. And then in the class, we make a struct for each one. Read config file, we'll just go through the configuration file and then just have a bunch of gets to pull the information out. So this is what the config file that I made looks like. We have an object for Canon with the yaw maximum and minimum in degrees, the pitch maximum and minimum in degrees. These numbers were calculated because the model I'm using needs to have an initial rotation. So these are the numbers that I get from the physics or the midterm document. Canon's positioned just above the origin. Limited range for yaw and pitch, the yaw between -quarter pi and quarter pi, and the pitch between 0 and 3/8 pi. So that's what these numbers are with the addition of the initial rotation. For bullet and cannonball, we just need the size of it, the damping, the mass, and the velocity. For the laser, it has a distance limit in case it gets too far. We don't want it to just go on forever. With mass, and then everything else is similar. And energy ball has all the same stuff, but it also has a time limit and a distance limit. So that's the header. So in the CPP, all the getters just get the structures that we made in the made it private, depending on what we need. And the read config. Apparently I forgot to actually finish these comments. Reads config file. And stores information in private structures. So in the read config, we open the file with the inputted file path name. And then for safety, we check that that the cannon is an object, and then that each value is a float. So when making changes to the .json file, to make sure that these are floats, add the decimal, even if it's a whole number. Otherwise, we just go through, store the information for each part. So go through the bullet, go through all the laser stuff, go through all the cannonball, go through all the energy, close the file, and we're done. So that's that. So then, after we read the config file, we load the cannon information, store that in variables here. Could just, I don't know why. Some stuff I decide to just keep using the get, some stuff I decide to store it twice. I think just the cannon stuff I store in main as well. And then GLFW stuff, make the particle world, which I don't think I have it open still. I decided to, the particle world, I didn't really see anything to change about except for removing the force registry because I'm not using it. So basically, constructor, deconstructor, add the particles to the world, remove the particle from the world, time step and integrate is all that the particle world does. And in integrate, I just removed everything except, or in time step, I just removed everything except for integrate particles, because each particle will handle its own movement and gravity and everything there. Since I'm talking about that anyways. Same thing with the base C particle class. This is just everything that every particle needs. It needs a position, velocity, acceleration, mass, and its damping value. And then the getters and setters just need to be there so that we can get and set the values. And then each cannon type inherits integrate and changes it depending on the particle. So the CPP file didn't really change, except again, I realized wasn't using the applied forces stuff, so I just removed it since it was doing nothing anyways. Which is why I made the cannon shot, because while every type of shot has all the particle information, every type of cannon shot also has a boolean to keep track of whether it's alive and what type of shot it is. I didn't end up actually using the type for anything, but I'll explain what my thinking for that was in a little bit. Otherwise, every type of cannon shot after this will have its own integrate and setting and getting for is alive in type. So this is what I was missing for project 1. Glad I finally figured out what it was so that I could actually inherit the classes for this. So yep, just basic getters and setters. This integrate does nothing because each subsequent class will handle itself. So we make the world, set everything we need, open our shaders, same basic shaders, solid color or wireframe for everything. Run load the models, which is the same from graphics in project 2. Just open the file that has the list of all the model names and save them, close the file. Then I make the platform and the cannon mesh using the cannon's start information. Add them both to the vector of stuff to draw. This is the same camera stuff to make the camera face the origin that I used in project 2. And then we hit the main loop. Again, very similar stuff here. I really like the FPS title stuff, so I copied it from the simple game app again, which just keeps track of the FPS. So this was the bigger difference since I'm actually inheriting this time. We just integrate every particle that is in the world, update the position of the mesh compared to the particle. If it's alive, we remove it and erase it, and that's all we have to do here. And then this is just GLM draw stuff. And override color and wireframe. So then in key callback, camera stuff is all the same. But we also have the arrow keys. So this is, thank you Epic Games. So this is where I figured out the math for the initial, or for the maximum minimum, and then once I had it all working, then I made the config file. And because I decided to write the config file in degrees, I have to convert it into radians here. But basically, I have this cannon speed, which is multiplied by delta time. And if we press up on the arrow keys, then we add the cannon speed to the pitch. Yeah, I was thinking if I need to change this to radians or not, but no, this works as is. But then we compare it to the maximum, because this cannon pitch actually is in radians. Anyways, the cannon pitch maximum is 7 pi over 8. And the minimum is pi over 2. So if we press the button and we're past the maximum, just don't change it and update the mesh. Down, we subtract it, same logic. Right, we change the yaw. Going left, rotating left around the y-axis, pressing right. is yaw max. So then if you press 1, 2, 3, or 4, I don't remember. No, I remember why now. I make the velocity here because I need it in cannon shots rather than calculating it as well. Basically, anyways, start by calculating the velocity. To get the real cannon pitch, I have to subtract. So this is the world angle from the origin. Subtract pi over 2 for the pitch. Subtract pi for the yaw. Take the cos times the cos of the yaw and pitch to find the z. Take the sine of the pitch to find the y, and take the sine of the yaw times the cos of the pitch to calculate the x. Normalize it, multiply it by the velocity from the configuration file, and then run our add cannon shot for the bullet. Starting at 1 below the cannon position, you'll see why when I run it, with the inputted velocity. And then do this same thing for 1, 2, 3, and 4, with the difference being multiplying the velocity to get the magnitude and changing the type. So then in cannon shot, I make a cannon shot pointer, set some default color and scale just in case something goes wrong. So for the bullet, we pull this mass, damping, and scale all from the config. For acceleration, I decided to go with -9.8 for the bullet and cannonball, because they are affected by gravity more than the other two. For the laser, same thing, pull the size, damping, mass, velocity, magnitude, and distance. So we set all those. The laser is affected by gravity less, so I decided to go with -3.2 down. Set its color. For the cannonball, size, damping, mass, velocity. Velocity is set when we press the button. So mass, damping, size. And for the energy ball, same thing, but we have a time limit and a distance limit. So set the energy ball damping. The energy ball is unique in that it accelerates in the same direction as its velocity. I found a magnitude of 2 to give it some actual speed so that it doesn't just sit there. And then at the end of each of these, we make the cannon shot equal to it, the one that we made for the specific type. Add the particle to the world, push the particle onto the vector of cannon shots, and add the mesh at the same position with the cannon shot scale. So the bullet and cannonball have the simplest class files. The bullet just has its own new integrate, where because I took out the applied forces, I decided to divide the acceleration by the inverse mass so that it's affected by gravity depending on its mass. Otherwise, the position follows the steps, and then we apply the damping after. And we only integrate if the bullet particle is alive, and when it reaches the ground, we set it's alive to false. For the laser, we need the distance from the cannon until it dies, which means we also need to know the distance it is from the cannon, which means we also need to know where the cannon is. So, the cannon gets its position from the config file, which means if this ever changes, we need to change it in those classes, which I think is, yeah, is done here. So we have a distance limit of 100. So when we make it, we pull this number from it, and while we're going, we check the distance from the cannon, and if it is greater than that distance, or the position is that reaches the ground, then the laser is no longer alive. And same math for the velocity. Then the cannonball, which I realized afterwards is just the bullet, but with a heavier mass. But rather than delete these and change stuff on the bullet, there might be a future where I actually do something different for the cannonball. And the energy ball has the most that's different because it has multiple death conditions. It has a time limit death condition, a distance death condition, and if it somehow hits the ground, it also ends there. So similarly to the laser, we need its distance from the cannon and the cannon position. So set its defaults in the constructor just in case we don't read it properly. We don't read the config file properly. Then in integrate, the energy ball is not affected by its mass, so we don't do anything in the velocity. We just add the acceleration times delta time to the velocity, and then apply damping, check how long it's been alive for, and then check its position, or if it's been alive for too long. Otherwise, I think that's basically it. So let's run it. I've decided to forego the harder marks and bonus marks for this because I really don't have a reason. This is what I've got and I'm submitting it. So similarly to before, you can move the camera if you want to change it. Otherwise, you can kind of see what's going on from here anyways. Left arrow key rotates the cannon left. Right arrow key rotates the cannon right. Down moves it down. Up moves it up. So I am holding the arrow key, not just pushing it. You can push it and give it if you want to be a little bit more precise. But now if I press 1, fire a bullet, which has a nice little arc. If I press 2, fire a laser, which is affected by gravity much less. It just kind of goes off. Pressing 3, cannonball. Like I said, or here, I actually gave the bullet and the cannonball the same starting velocity. They just have different mass. They even have the same damping. So if I press 1 and 3 at the same time, you can see that the bullet goes much farther and has a much longer arc. And finally, number 4, the energy shot. Just shoot it out and it keeps moving along the same path. And similarly to the fireworks project, you can just keep hitting buttons. And just to show that they are actually changing depending on where the cannon's positioned. And we can fire almost straight up as well. And if we lower it straight down, almost, we see that the laser ends much faster than when it was raised. And because the energy ball is horizontal to the plane, it will never actually hit y equals 0, so it just kind of keeps going on forever. And that's basically it. This can be run in debug or release on x64. The models I'm using are the R Stanford Bunny, and this is the link to the Creepy Cats 3D Sci-Fi Kit Volume 3, where I got the floor and cannon models from. Otherwise, I think that's everything. Bye.